So energy is a topic I think mainly for middle school at this point, but a lot of the concepts inside can be tested in physics or biology. And so you'll want to know just about energy in general. Okay, so energy is difficult to study because there's no set textbook. Unlike biology, chemistry, or physics, where there are very well-known, solid, fundamental textbooks where you can read out of, there's no real like energy textbook. You just have to read Wikipedia a lot of the time because Wikipedia is full of lots of random information. And as I mentioned, energy includes a lot of different subjects, and you might actually see these types of questions, especially in the high school round, in life science or the physical science categories. A very common question that they ask is sources of energy. So I updated this graphic here to get the most recent one I could find, which is 2019. And if you look here, you see that we rely mostly on petroleum. Everything's a plurality at this point. Petroleum 37%, and then natural gas 32%. Coal is going down over time, 11%. Nuclear power is 8%. And then of this kind of classification of renewable energy, we can see that wind provides the most. Biomass provides the most if you count it as one category, and then wind, and then hydroelectric, solar, and then geothermal in the United States. Now the world has different numbers than the United States does, but because Science Bowl is a science competition in the United States, it has its own. It focuses a lot on U.S. consumption. Though we can also ask about world consumption. So one important statistic you'll want to know that's very recent and might be tested is that for the first time in 130 years in the US, renewable energy has actually exceeded coal by consumption amount. And a lot of you might be wondering right now, this is a trick question the Science Bowl likes to ask, what renewable energies exceeded coal for the first time in 130 years? How was solar panels weren't invented until recently. How was it that 130 years ago there was more renewable energy usage? And the answer is renewable energy includes biomass. So we used to just burn logs for fuel. And then we discovered coal and it became really, really hot during the Industrial Revolution. We found out we can burn coal for energy. But nowadays we're moving back towards renewable energy, towards more sustainable energy source. So the amount of coal is steadily going down. Renewable energy is steadily going up, though it's still a pretty small amount. Natural gas is being used more and more nowadays as well. And we're going to touch upon each of these renewable energies in this presentation. But first, let's talk about non-renewable energy. So the forms of energy get tested quite often in Science Bowl. So this is just stuff you'll need to memorize probably. Coal is a form of non-renewable energy. It's very popular during the Industrial Revolution. And coal is a fossil fuel that was formed when you had all this decaying organic material, like plant matter from many millennia ago, and it just under high heat and pressure and over time, it turned into coal. And so coal has different grades: lignite, subbituminous, bituminous, and anthracite coal. The lignite coal is more like plantish matter, and these are in grade order. And the higher the grade of coal, where anthracite is the highest, the more attractive it is a lot of the time because it has better fuel content and less impurities. It's more of a pure energy source. And so this is why in Science Bowl, the answer is almost always anthracite. If they mention coal at all, normally you're going to be asking something like, what is the highest grade of coal, or the most desirable form of coal, the least impure form of coal, the most pure form of coal, the most expensive form of coal to buy, the rarest form of coal. The answer to all of these would be anthracite. It is the best coal essentially that you can get. But unfortunately, that means that it's expensive too. Bituminous, subbituminous, lignite, these all have their own purposes as well. Natural gas is made up of a bunch of smaller hydrocarbons, mainly methane, with the chemical formula CH4. The US is moving more towards natural gas now because of the fossil fuels. It's considered a cleaner fossil fuel. Now, fossil fuels, by definition, are not extremely clean, but it is cleaner than, for example, coal is. So we're moving more towards natural gas. Petroleum and oil, they can be extracted. Natural gas too by the controversial process of fracking, which you'll need to know about. So in fracking, we inject a high pressure, saline solution, fracking fluid into the earth, and we're getting all the natural gas and oil about it. But in exchange, we're pumping huge amounts of wastewater essentially into the earth. We're destabilizing things. There are hypotheses that it can also trigger miniature earthquakes. Where in Oklahoma, I think 3 years ago, in Oklahoma, fracking is very common. I think there are more earthquakes in Oklahoma than California. 3 or 4 years ago, and people say that might have been because of this constant fracking activity. So fracking, very controversial, and a lot of environmentalists are against it. Okay, moving on to renewable energy. So hydroelectric power in hydroelectric power, we're trying to use, water is constantly running, and we want to use this kind of energy and try to turn it into electricity for our own usage. So for dams, we're using gravitational potential energy, right? We are like blocking all the water up against a dam, and then we can let it through, and it can flow through and turn turbines. And when these turbines rotate, we can produce electricity. And the biggest dam in the world is the Three Gorges Dam. It's relatively recent. It's on the Yangtze River in China. And I believe that in the news, they reported that when it was first turned on, the Earth's rotation slowed despite like a very, very small amount temporarily, just because of the sheer amount of water that was being affected by the dam at Three Gorges. Wind power is also very common. Wind power, you might have seen all these turbines kind of just like flowing in the wind. The concept of wind power is very ancient. In a lot of civilizations, you'll see like mills that would be used to crush grain by using the power of the wind. So now we're using the wind power to make the electricity. We put them in wind farms offshore or in high altitudes where there's lots of wind, so it's efficient. And the general formula you want to know is the power is proportional to the cube of the wind speed. So we use a lot of wind power a lot of the time, but it has its side effects as well. Some people complain about the noise, its effect, like visual effect in communities, as well as how it can kill birds. Solar power is another alternative we use. Solar power, though, of course, is more efficient if you live where there's more sun. And solar power relies on the photoelectric effect, where the light energy is exciting the electrons. And we're converting essentially this light energy into this direct electrical current that can be used to power things. So these three major forms: hydroelectric power, wind power, and solar power. Continuing on, we have other forms. You might have noticed geothermal was really small in America. Geothermal power takes advantage of the energy of the earth. So the earth has heat coming from it. And there's a gradient of temperature from the core of the earth to the surface, and we can kind of take advantage of that energy in the earth to make electricity as well. And so where this is really common is Iceland. In Iceland, again, very, very common science question, it's somewhere around like 90% of the electricity of Iceland is produced through geothermal energy. And that's because Iceland is on a hotspot. There's a lot of tectonic activity, so they can take advantage of this geothermal activity for power. So when you hear about geothermal energy and like where it's the highest, the answer is Iceland. You also have bioenergy. And in bioenergy, you have like you're using lots of living material or previously living material, and you're trying to make power out of it too. So biomass, wheat, straw, corn, sugarcane, right? You can use these to supply fuel and electricity. In the past, we would just literally just burn logs, leaves, right? That's why renewable energy was actually the most common source of energy for most of our civilization's history, because that's how we used to get our energy before we discovered like fossil fuels or how to utilize these other renewable energy sources. You have biogas, where you can use the methane that's coming from decomposing waste, bioethanol that's being produced from a lot of these crops like maize, sugarcane, sweet sorghum, and biodiesel that you can produce from leftover oils and fats. You also have nuclear energy. So nuclear energy, we're relying mostly on nuclear fission, right? So if you look at a schematic over here, you're kind of splitting this atom into different atoms. And when these atoms split, they produce a massive amount of energy. You probably know this from learning about the atomic bomb, right? It produced a huge amount of energy. But here in nuclear energy, we're trying to harness that power, not for destructive purposes, but to generate a lot of electricity that can be used to power our civilization. But it's very controversial because sometimes there are nuclear disasters, there are meltdowns at nuclear reactors. You might have heard of the 3 Mile Island incident near the East Coast, which this was in the 1900s. And, it was very controversial. And nowadays, the US is not building as many nuclear power plants because there's controversy over things like these kind of like meltdowns, what do you do with the waste? Because the waste from creating nuclear power is radioactive. So like, what do you do with it? The government still has not figured out permanently how to store this nuclear waste, because none of the states wants to have nuclear waste. And so it's very controversial what to do with that. And there are also more recent nuclear events that you might not have heard of, like Chernobyl, this documentary on Netflix. Chernobyl in Ukraine, there was a huge nuclear accident there too. It irradiated the entire environment. Even today, we're seeing a lot of the effects on the local animals and plants near the area. You had the Fukushima nuclear disaster that was triggered by a tsunami and an earthquake in Japan. And there's radiation that spread out as well. And this is, I think, in like 2011, so much, much more recent. And then so another thing people are thinking about, though, is nuclear fusion. Nuclear fusion produces a lot more energy. In fact, That's how our stars produce energy, is through nuclear fusion. So if nuclear fission is taking a big atom and turning it into two smaller things, nuclear fusion is taking two small things and making something bigger. And you can produce a lot of energy through this too. It's very difficult to do. And in comparison to nuclear fission, much harder to accomplish. We're trying all sorts of different things like tokamak to try to accomplish nuclear fusion. But it's definitely much more difficult to accomplish than nuclear fission energy is. So just to review the renewable energy and non-renewable energy based off the chart here, right? We have petroleum, natural gas, coal. These are like non-renewable. Nuclear is usually lumped in renewable energy. And we have different types of the geothermal energy from the temperature gradient of the earth, solar energy from the light from the sun, hydroelectric energy from the movement of water. You have wind energy from the wind, and you have biomass energy. You can be converting this all sorts of decaying biomatter into fuel or into the production of electricity. And so another thing that you might want to know, just a general rule of thumb or heuristic, most forms of energy consumption work by, it's not like you're turning water directly into electricity, right? The way most things work is in the end, you're turning some sort of turbine generator. And when you turn it, it produces electricity. And how you're turning it really depends. So in hydroelectric energy, you have the water that's literally just turning the turbine can produce energy. But in most forms of energy, what you do, for example, in nuclear energy is you're using this kind of reaction to heat up a body of water. And this water turns into steam, right? When you heat up water, it becomes really hot, it turns into steam. And the steam floats up and turns these turbines. So that's how most energy, electricity is actually produced. Same thing for things like coal, right? You burn the coal, heats water, turns into steam, turns a turbine, and you get your electricity. Okay, great. So that is our general crash course into energy. And now I'll be answering any questions that anyone has from here.